So, hello everyone, today we are going to focus on empirical formula. So, if we just... So, when a new compound is made, it is analyzed experimentally to determine the percentage composition by mass of each of the elements present. So from the stated empirical formula of the substance can be worked out. We can find the empirical formula of a compound from the percentage masses given. So here are the steps. So list all the elements in a compound. Above them write the percentage or mass in grams. If it's not in percentage, then the mass will be in grams. Then divide each percentage or percentage mass by the AR, and then turn the numbers you get into a simple ratio by dividing or multiplying by well chosen numbers. And 5, get the ratio in its simplest form by cancelling. And this should give you the empirical formula of the compound. Now, that to me seems complicated, but that's the instructions I was given, so I found an alternative way, and this mnemonic here was given MADAR, and this stands for mass AR divide ratio. I found this very simple, so I do recommend you using this one here. So M stands for mass, so you write down the mass of each element. A stands for AR, so you write down underneath the AR. D stands for divide, so you divide the percentage by the AR. And ratio, R stands for ratio, so you turn the numbers into a simple ratio. Now that may seem slightly better than the first instruction given, but we'll try some questions and soon you'll get the gist of it. So question 1. Hydrocarbon X, so it's an unknown compound X, contains 92.3% carbon by mass. Calculate the empirical formula. So MADR, which is our mnemonic, MADR. So we start with M for mass. So you write down the mass of each element. So we have carbon, which is 92.3%, and it doesn't mention anything about hydrogen, so you're probably wondering where I got hydrogen from. And it says in the question, a hydrocarbon, so it only can involve carbon and hydrogen, so the remaining element will be hydrogen. And so what I do is a simple calculation, so I do 100 minus 92.3% to get 7.7%, which is the remaining and mass for hydrogen. And so I move on to AR, so I write down underneath the AR, so underneath the percentage masses. So under 92.3% for carbon, I write 12, which is the mass, and then for hydrogen, I do 7.7 over 1. And so then I divide the percentage by the AR, so I get 7.6919 for carbon, and hydrogen I get 7.7. So then I rounded 7.6919 to 7.7, seemed logical, and so I turned the numbers into a simple ratio. So I get 7 to 7, and then I simplified it to 1 to 1. And the empirical formula was CH. Now, we don't write C1H1, we just write it as CH. Second question, I hope that made slightly more sense. So here's a slightly harder one. So compound X, an unknown compound, has 37.2% carbon and 55% chlorine by mass. The remainder of the compound was hydrogen. Calculate the empirical formula. So we write down our mnemonic, MADAR. So begin with M for mass. Write down the mass of each element. So we have carbon, which was given in the question, 37.2. Chlorine, which was also given in the question, which was 55%, and what was the remaining element? Now, hydrogen. Now, how do we work out the percentage mass for hydrogen? Simple mass calculation again. So we do 37.2 plus 55, which equals 92.2%, and since we're dealing with percentages, we know to do 100 minus 92.2 to give us 7.8%, which is what the mass for hydrogen is. Now we move on to second step, A for AR, and we write down underneath the AR. So we have carbon, 37.2%, divided by 12, for hydrogen, we've got 7.8 over 1 and 55 over 35.5. Now we go on to D, so you divide the percentage by the AR, so we get C carbon, which is 3.1, hydrogen, which is 7.8, and chlorine, which is 1.5. Now we move on to step R, R for ratio, and turn the numbers into a simple ratio. So I had 3.1 to 7.8 to 1.5. So I multiplied these by 2 to get 6.2 to 15.6 to 3.1, and then I divided it by 3 to get 2 to 5 to 1, and so the empirical formula was C2H5Cl. So now it's your turn to have a go. So this is an actual exam question. So this is a separate one and that's a separate one, and don't work out the molecular formula yet, we'll do that in the next video. For now, just work out the empirical formula. So pause the video and have a go. And by the way, these are 4 to 3 marks, they're a huge chunk of marks, so it is really important for you to get your grasp on the calculating empirical formula. So pause the video and have a go, and we'll look at the answers shortly. So here's the answer for the first question. So percentage of oxygen by mass. So this is how you're going to give yourself the marks. So if you wrote out the AR for carbon, hydrogen and oxygen, and you divided it by the percentage masses, then that would give you 1 mark. And if you worked out the percentage mass for oxygen, that would also give you another mark. And then to get the other mark, you would want the final ratio, and so which was 3 to 4 to 3. And so the empirical formula was C3H4O3. Now for the second question, the answer was 74.1% for oxygen, and so you get 1 mark for that, and you get another mark for this ratio here, so N2O5. And do notice here that we haven't put NO2.5 because we don't really want any decimals, so smartly the person whoever did this notice that 2.5 multiplied by 2 is 5, and so if we multiply both of these by 2 you would get N2O5, which is a nice round number. So that's it for today, and so in the next video we will look at molecular formula. If you do have any questions or anywhere I could improve in these videos, please do comment down below, and please do subscribe, comment and like.